This is Dr. D. Govardhan, Professor and Dean, Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, I am discussing radiation, the concept of shape factor in heat transfer. When heat is incident on any object, the entire heat energy is not absorbed by the body. If it is absorbed, the type of body is called black body, but generally in nature the type of bodies are not exist. Here the black body, the amount of energy that is absorbed by it now, entire energy is again emitted by it now. That is absorbed energy is equal to emitted energy. But some other bodies are there now. The part of the incident energy is absorbed. Some part it may be reflected. Sometimes some part that is reflected, that is we called effective bodies. It will absorb some part of the incident energy, some more is transmitted. So depending on type of the objects, the heat energy flows. It may be absorbed, it may be reflected, it may be transmitted. Here the fraction of heat energy that is absorbed by the body, that is fraction means it is the ratio of energy absorbed to the total energy that is incident on that object is called absorptivity of the surface. Generally it is represented as alpha. The fraction of heat energy which is reflected is represented as here rho. That means it is ratio of the amount of energy reflected to the amount of energy that is incident on the body is called reflectivity. And the third one, the transmissivity. It is the ratio of the amount of energy that is transmitted to the total energy that is incident on the object. These properties at a particular wavelength is called monochromatic properties, which are represented as delta, gamma, and rho delta and tau delta. The first one is alpha delta, the second one is rho delta, and third one is tau delta. In general application, the total properties are considered. That is, here we are taking monochromatic properties. That is, they are particular to the particular wavelength. But generally, while doing the calculation, the total properties are considered. However, some special applications of monochromatic properties are used now. So, the sum of the energy which is transmitted and absorbed or reflectivity, it should be equal to the total energy that is incident on the body. Hence, alpha plus rho plus 2 equal to 1 now. Already just we discussed opaque surfaces. Opaque surfaces are the surfaces of the body which will absorb as well as the transmitted energy. It will not reflect any energy. That means alpha plus rho equal to 1. Black surfaces, these are the bodies which absorb the total energy which incident on it. Hence, alpha is equal to 1. That means rho equal to 0 as well as the tau is also equal to 0. So, Kirchhoff laws, this law is always related to the black body. It gives the relationship between the emissivity as well as the absorptivity of the black body. This states that the absorptivity of a surface at a given temperature and wavelength is always equal to the emissivity of the surface at the same temperature and the wavelength. For practical applications, the statement is simplified as that is here now epsilon is equal to alpha. Here the concept of shape factor. The shape factor is most important to determine the amount of heat energy that is transferred to a particular body by the radiation process. Here the thermal energy radiation from the surface generally travels all over the space in all directions above the surface. But a certain portion of the radiant energy emitted by that particular object from that surface, it only reaches the other body, can be observed or transmitted or reflected by that body. The fraction of energy emitted by a body that reaches the body, other body, maybe by using the modes of transmissions or observation or reflections, can be calculated if you know the observability of the surface. Here case 1 is given. Black body means all the incident energy will be observed. Case 2, opaque or grey bodies are there. The part will be observed and part will be reflected. The part of the reflected energy may again reach the original object from which the energy receiving by the first body, that is original, which will be disposed of as well as the original radiation. The shape factor is defined to facilitate this study a new concept. Here the shape factor here, when we are taking already we discussed, in the universe the black body will not to exist. That is when the energy is received from a body, some part it may be absorbed, some part it may be reflected. A reflected means that part it may goes toward the other object from which this object is getting the thermal energy. So in order to facilitate the amount of energy that is transmitted to that original body from which the energy is getting, the shape factor concept is utilized. The several terms generally used for the shape factor synonymously, they are angle factor, view factor, geometric shape factor are some of the important terms. The shape factor of surface 1 with respect to the surface 2 is defined as the fraction of radiant energy emission from the surface 1 reaching the surface 2 now. These fractions generally is denoted as energy from the 1 to 2. That means the amount of energy received by the body 2 from the body 1 now. The shape factor depends on the geometric position of the surfaces. If the surface 2 includes the surface 1 completely, then the shape factor of 1 to 2 is treated as equal to 1. Here from 1 to 2 means here 1 is nothing but the object which is giving the energy, 2 is the object which is receiving the energy from the 1. If two surfaces is not visible to each other, in that case the shape factor of 1 with respect to 2 is treated as 0. The shape factor depends upon the distance between the two surfaces and the area of the surfaces. The two coaxial circular discs facing with each other will have a higher value of shape factor if the distance between them is closer. For same central distance, larger area will have a higher shape factor value. That means more amount of energy that is absorbed by the second body from the 1. The expression for the shape factor. Here consider two blocks. Here A1 and A2. They are placed this in a space having some distance here, assume here HR, sometimes it is also represented as L now. Now the area of the first one is represented as A1 and the second one is A2. That is the amount of energy emission from A1 and reaching A2. That is nothing but energy is here now flowing from 1 to 2 position. it is represented as Q12 it is equal to A1 into F1 and F1 to 2 now into EB1 now. That EB1 is nothing but total amount of energy that is emitted, and F12 is representing the shape factor of 1 with respect to the 2, and A1 is the area of the object from which the energy is emitted now or emitting. This is completely observed by the surface A2. If the block is if the A2 block is the block body. Similarly, the quantity of radiant energy from A2 reaching A1 and observed by given by Q21 is equal to A2 F21 EB2. Here we have taken the first equation is representing the amount of energy that is observed by the A2 which is coming from A1. It is represented by the Q12 equal to A1 F12 into AB1. Here the body A1 is having higher temperature than A2. But since it is a block, the amount of energy which is coming from the A1, it is completely absorbed by the A2 now. But A2 is also block body, hence it is also emitting certain energy from its surfaces. The amount of energy received by A1 from A2 is given by the Q21, that is energy from second body to one body is given as A2 into F21 into EB2. It is represented in equation B now. When the surfaces A1 or A2, if they are at the same temperature, that means the amount of energy emitted by the body A1 should be equal to the amount of energy received by A2. At the same time, the energy emitted from A2, it is completely absorbed by the A1 once again. Or it can be represented as the Q12 is equal to Q21. Both are equal now. Since from these equations now, the surfaces A1 and A2 are at the same temperature. These two quantities should be equal as no heat transfer is possible. That is EB1 is equal to EB2. This is nothing but energy emitted by first block body and the second body, both are equal because both are the block bodies having the same temperature. So from this relation now we are having Q, that is the quantity of heat energy flowing from 1 to 2 is equal to the quantity of energy flowing from 2 to 1, and EB1 is also equal to EB2. From this relationship we got A1 F12 equal to A2 F21. Since F12 is not equal to 1 now, why? Because the diameter it depends upon F21 as well as the F12 depends upon the distance between the two bodies. Since the distance is relative distance is same, hence not required to consider here now. The second one is a geometrical shape. Assume both are having the same geometrical shape. Third one is the area of which is exposing. These are also important. If they are not at all equal, then it can be written as A1 into F12 equal to A2 into F21. This is represented in equation number 3 now. This concept is known as, that is A1 F12 equal to A2 F21. This concept is known as reciprocity theorem for the shape factor and will be used extensively in many situations to determine the net heat energy that is observed by the any object. If the two bodies are having different temperatures, that means that net energy according to these equations flows from the body which is having higher temperature to the body which is having lower temperature. Hence, the net energy received by the body which is having lower temperature is given by Q12 minus Q21. Because both are block bodies, both will be reflected certain energy, but the object which is having a higher temperature, it is transmitted more energy. Hence, the net energy that is flowing to the body which is having lower temperature is given by Q1 is Q12 minus Q21, which is given by A1 F12 into EB1 minus EB2. Here the condition is here A1 F12 is equal to A2 F2. Hence, we are taking it only one factor now. Here some of the cases we are considering regarding shape factor. The shape factor is equal to 1 for any surface, completely enclosed by the another surfaces. The best example is one ball is inserted into the another ball now. In that case, the heat energy which is flowing from the body, which is having higher temperature to lower temperature, in that case, the shape factor is treated as 1. The second case, the shape factor is also 1 for infinite parallel planes now. If the two surfaces are placed in such a way that they are parallel to each other, in that case also the shape factor is 1. From one inner cylinder to outer cylinder of long coaxial cylinders. That is cylinder is nothing but it is having as this is nothing but treated as a cylinder. Here one more cylinder is inserted in it now. Both are having the longer in length. And the axis also, coaxial mentioned, the axis of both the cylinders are coincident with each other. In that case also the shape factor is equal to 1. The inner and outer concentric spheres. Okay, in that case also the shape factor is 1. So these are the cases in which the shape factor of two bodies is equal to 1. Note, the reciprocity theorem can be used to find the shape factor of outer to inner cylinder of the sphere also. For small element to dA1, here is given now. For small element to dA1, to a parallel circular disc of radius is given, one more is given, A, shown in figure 13b now. At a distance of L, the shape factor is equal to A square divided by A square plus A square now. Here in this case, dA1 is nothing but a small area, that is the radius also, we are not at all considering, that is nothing but treated as small when comparing with the second one now. Assume just AB is representing the radius of the biggest circle. So the that is the shape factor is represented because E is representing the radius of the circle. L is the distance between the two centers of the circles. Then the shape factor is given by the relationship A square divided by A square plus L square now. And in case 2, if two unequal coaxial parallel circular disc of radius A and B at a distance L from each other, the shape factor from smaller to a bigger disc of radius B is given by here F12 is equal to is given L square plus A square plus B square minus under root of L square plus A square plus B square under root divided by 4A square B square divided by again 2A square. Okay, this is the equations now. So here F12 is equal to here the total sum of L square plus A square plus B square minus of under root of L square plus A square B square divided by 4A square B square whole divided by 2A square now. Okay, these are the relations generally used to determine the shape factor of 1 to 2. If the two are now coaxials, parallel, unequal discs are given of radius A and B given, then it can be determined by using these equations. Okay, the shape factor relationship together with the reciprocity theorem are used to evaluate the shape factor value in certain situations. Here the shape factor is equal to what is the value we have taken, A1 F12 equal to A2 F21. This is given now. Now consider the surfaces now A1, A2 and A3. The three surfaces are given. The first of such rule is that is the shape factor of 3 to 1. That is it is given here, but heat energy flowing from 3 to 2 and 2 to 1 is given. Hence we can take here shape factor of 3, 1, it is at theta 1 to 2 is equal to the sum of the shape factor of 3 to 1 plus shape factor of 3 to 2 now. This is obvious that this relation as the energy reaching an area is the sum of the energies reaching individual parts of the area now. Generally, if it is there are number of plates are kept down, the shape factor it gives the Fij to KLMN is given by Fij plus Fik plus Fij plus Fim and so on. That is the sum of the shape factor with respect to the object I to individual surfaces such as J, K, L, M and so on. Okay, multiplying RHS and LHS equations by the areas. So we got this is nothing but it is equal to the shape factor what we considered earlier now. Then using reciprocity theorem, A1 plus A2 F1 to 3 is given by A1 F13 plus A2 F23. It is given. This is nothing but reciprocity theorem is applicable for the three objects which are there here represented as A1, A2 and A3 now. The total energy, these equations can be stated as the total energy received by the areas A3 from A1 and A2 is equal to the sum of the energies received from the areas A1 and A2 separately. These relations are very useful, particularly in evaluation of shape factor for various geometries at the same time which are separated by certain distances. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.